Welcome to the channel of veterans. What is a secret? A secret is essentially a set of information that someone does not want others to know. Let's take an example. Suppose there is a person, Mr. A, who has been abducted by aliens. Mr. A doesn't want to mention this incident to anyone. He wants to keep this event buried in his heart forever. So, this alien abduction case becomes a secret. This secret is divided into two parts. One is the person involved, Mr. A, and the other is the abduction event itself. The person involved, Mr. A, can also be referred to as the observer. The abduction event can be seen as a form of information transmission. At this point, we break down the secret into the observer. There is a famous thought experiment related to the observer and information transmission. Many friends are familiar with this experiment, called Schrödinger's cat. Before the observer opens the box, no one knows whether the cat is alive or dead. So, Schrödinger said that at this moment, the cat is in a quantum superposition where both the alive and dead states exist. The cat is both alive and dead, and so on. Now, let's think about whether there's a similar possibility with the alien abduction case. If Mr. A never reveals his secret, then this abduction case remains in a quantum superposition. It both exists and does not exist until Mr. A discloses his experience of the abduction, collapsing the quantum state. The moment it collapses, the abduction case becomes real, entering a truly existing state. Some people may say, isn't this nonsense? Whether or not A. Jun told his story, the kidnapping case still exists. The suffering that the aliens brought to the A Army when they were imprisoned was real. How can we say that this incident did not exist? But in fact, this is not a ridiculous question. 100 years ago, Einstein also asked the same question. Einstein asked, if we don't look up at the moon, does the moon not exist? He wanted to know whether the reality of this world depends on the observer's observation. If there are no observers, does our world still exist? This is a very classic question. Today, we are going to explore the probability of the universe's existence. Does the universe we inhabit really exist? To understand this strange story, we need to start from the beginning. Let's rewind to May 19, 1919. British scientist Eddington organized a monumental observation under immense pressure. He wanted to prove that Einstein's theory of general relativity, proposed 4 years earlier, was correct. A reporter claimed 3 understood relativity. Eddington asked, who is the third, implying he and Einstein understood it, showing its complexity. Is that so? Eddington thought for a moment, and then asked the reporter, who is the third person you're talking about? Eddington's tone was quite bold, as if besides Einstein and himself, no one else could understand relativity. This also shows that in 1919, relativity was indeed a very cutting-edge theory. At that time, World War I had just ended, and there was a strong animosity towards Germany throughout Britain. Eddington, as a British man, requested the Royal Astronomical Society to invest a large sum of money to prove the theory of a German scientist. This requires courage. It also fully demonstrates Eddington's relentless pursuit of science. Eddington's goal was to use the rare phenomenon of a solar eclipse to measure the positions of stars behind the sun. He set up 2 observation points, one in Africa and the other in Brazil. He himself arrived at Principe Island in Africa. On the morning of the solar eclipse, the weather was terrible. It was stormy and the sun was completely obscured. Just as the moment of the solar eclipse was approaching and everyone was starting to lose hope, the wind died down and the rain stopped. The weather improved. Eddington immediately began the intense process of taking photographs. He and the researchers in Brazil took pictures of the same star in the direction of the sun. By comparing the 2 sets of photographs, they found that the star had indeed shifted from its original position. This indicates that the light from distant stars is bent by the sun's gravity. Eddington's experimental results shook the world. This experiment meant that Einstein's theory of relativity was correct. This experiment permanently changed our understanding of space-time. In the past, we believed that time flowed uniformly throughout the universe, but this view is completely wrong. Time is not a constant, time is a variable, and it differs in every corner of the universe. Eddington's vow tells us that the variation of time depends on 3 factors: gravity, motion speed, and the observer. Let's first talk about the effect of gravity on time. Now, let's fast forward to 1964. At the White Sands Missile Range in New Mexico, 2 V-2 rockets were launched in succession. The goal of these rockets was to search for X-ray sources beyond the atmosphere. Soon, the reform counters on the rockets received signals. One of them is coming from the direction of the Swan constellation. This is one of the strongest X-ray sources observed from Earth. However, in 1964, people didn't yet understand what this signal meant. 7 years later, in 1971, the National Radio Astronomy Observatory in the United States observed the X-ray source in Cygnus again. Scientists discovered that this is a binary system, with a massive companion star orbiting around a gravitational center. Later, scientists calculated that the mass of this companion star is about 41 times that of the Sun. This massive celestial body is being pulled into an invisible hole, and the entire process releases a large amount of X-rays. This invisible hole is the first black hole discovered by humanity. This binary system is the famous Cygnus X1 in astronomy. Einstein predicted black holes. Cygnus X1 confirmed. Universe amazes. Light seems straight. Gravity bends. The discovery of Cygnus X1 confirmed this prediction. The wonders of the universe far exceed our imagination. For light, it believes it is always traveling in a straight line. And indeed, it appears that way when viewed on a two-dimensional plane. However, from a three-dimensional perspective, the immense gravitational source warps space-time into a curved state. So the light does not travel on a plane, but on a curved surface. It travels on a geodesic line. The larger the gravitational source, the more curved the space-time, and the longer the route the light travels. This means that the stronger the gravity, the slower time passes. For example, the nearest giant star to our solar system is Beta Centauri, which is 34 light-years away from Earth. Beta Centauri, twice the Sun's mass and 9 times its diameter, slows time. Black holes trap light. The space-time around it is also much more curved, so time in the Beta Centauri system passes much more slowly than in our solar system. The most extreme celestial bodies in the universe are black holes. Their gravity is so immense that it tears a bottomless pit in space-time. Once light enters this bottomless pit, it can never escape. From the outside, objects that are pulled into a black hole leave information on the surface of the black hole. So, at the surface of the black hole, time is frozen, or we can say that time has stopped. There is an inverse relationship between time and gravity. The stronger the gravity, the slower time passes. Since the universe is filled with gravitational sources of various sizes and strengths, there is no place in the universe where time is consistent. There are countless clocks in the universe, and each clock shows a different time. This is the variation in time caused by gravity. Next, let's introduce the second factor. That affects the change in time: speed of motion. In 1971, American physicists Joseph Haffel and Richard Keating conducted a very interesting experiment. This experiment cost a total of $8,000, making it the cheapest experiment ever to verify relativity. Haffel and Keating used this $8,000 to buy a few round-the-world plane tickets, which included seats for both of them and for a clock they brought along. The so-called Mr. Atomic clock refers to the 4 atomic clocks they brought on the plane. They flew around the globe from east to west and then compared the clocks on the plane with those on the ground. And something strange happened. The clock on the plane was actually 29 nanoseconds slower than the clock on the ground, which is equivalent to 1/1,000,000th of a second. This indicates that time slows down during motion. In fact, it's not just the clock that slows down. The heartbeats, thoughts, and aging processes of the people on the plane also slowed down. Everything on the plane slowed down. This phenomenon is known as the famous time dilation effect. Time dilation isn't felt because we move slowly. At over 30,000 km/s, over 1/10 light speed, it becomes obvious. Light travels 300,000 km in a second. How is that slow? Animation will illustrate. In other words, when traveling at speeds greater than 1/10 the speed of light, the time dilation effect becomes very apparent, and people can easily observe the changes in time. There's a chilling fact to consider. We think the speed of light is incredibly fast, but relative to the universe, the speed of light is actually quite slow. Light travels 300,000 kilometers per second. It circles Earth 7 times in a second. It reaches the moon in... The diameter of the Earth's equator is 40,000 kilometers. Light can circle the Earth 7.5 times in 1 second. The average distance from the Earth to the Moon is 384,400 kilometers. It takes light 1.255 seconds to reach there. Going a bit further, the closest distance from Earth to Mars is 54.6 million kilometers, and light takes 3 minutes and 0.2 seconds to get there. We can take a moment to feel this time. It's actually a very long duration. Light takes 8 min 20 sec to travel from Earth to Sun. It takes light 4.2. 465 years to travel from the Sun to the nearest star, Proxima Centauri, while the diameter of our Milky Way galaxy is 105,700 light years. Even traveling at the speed of light, it would take 100,000 years to get from one end to the other. It can be seen that from the scale of the universe, the speed of light is very slow, precisely because the speed of light is the destination. So interstellar travel on a cosmic scale is currently unattainable. Let's go back to the theory of time dilation, which was also discovered by Einstein and derived from Einstein's special theory of relativity. The following formula is the simplest version of the time dilation formula. This formula is very mysterious, and it can explain why aliens have not yet come to Earth. This is the wonder of mathematics. Mathematics can make precise predictions in physics. According to observations by American astronomer Hubble, all galaxies are moving away from each other, and this observation is an important piece of evidence for the Big Bang theory. Scientists have found that as the space in the universe continues to increase, time will expand in the newly created space. In the Milky Way's reference frame, time in other galaxies slows as the universe expands. Thus, the present moment here is always the first to appear. This is true for any galaxy. If we were in Andromeda, its present would be first. So, the present moment in the Milky Way always appears first in the universe. The Milky Way is our reference frame. It's not unique. All galaxies are similar. In Andromeda, its present moment is first in the universe. This is time dilation in relativity. Why won't aliens visit? If they take millions of years, we might have experienced 1 billion. They might not be advanced anymore, falling behind the Milky Way's civilization. This is the time dilation effect described in special relativity. If they take millions of years to reach us, we might have experienced 1 billion years. They might not be advanced anymore. They could be at a disadvantage. Time dilation suggests Earth might be the most advanced. We might have experienced 1 billion years or even longer. And no one can guarantee that when aliens reach the Milky Way, they will still be an advanced civilization. They might have already fallen behind the civilization of the Milky Way. Falling behind means they could be at a disadvantage. So what are they doing here? Time dilation theory shows that if the Earth is the most advanced civilization in the Milky Way, so Earth could be the most advanced civilization in the entire universe, which might be one reason why aliens don't come here. From the perspective of the Milky Way's clock, we are always ahead in the universe. Of course, this is just a speculation. We don't know if there are advanced alien civilizations in the Milky Way. What I've just discussed is the second variable of time, speed of motion. Now, let's introduce the third variable, observability. In 1979, the famous American physicist and great thinker John Wheeler, at the centennial celebration of Einstein's birth, a thought experiment was proposed that shocked the physics community. It's called the delayed choice experiment. Wheeler made a prediction that in the quantum micro world, the order of cause and effect can change. In 1979, Wheeler's theory was a radical and almost neurotic statement. Over the past decade or so, with advancements in science and technology, scientists have conducted Wheeler's delayed choice experiment multiple times. There are many versions of the experiment, but they all fundamentally convey the same idea. Now, let's take a look at whether the order of time can actually be changed. The scientists use lasers to emit photons and place a crystal behind the double slits. The crystal can convert the incoming photon into 2 photons, each with only half the energy of the original photon. These are 2 entangled photons. This means that by observing one photon, we can know the state of the other photon. At the end of the paths, 2 observers, A and B, are set up to observe which slit the photon passes through. If A and B are turned off, the scientists will see a wave-like pattern on the screen, indicating that the photons have interfered with each other. However, if A and B are turned on, there will no longer be interference fringes on the screen, showing that in the presence of observers, the photons only pass through one slit. This is the double-slit experiment. In the advanced double-slit experiment, extending paths, A and B paths extend beyond the screen. Photons hit the screen first. Off. Interference. On. In this way, the photons must first hit the screen before they can reach the observation points of A and B. At this point, if A and B are turned off, the screen still shows interference fringes. However, if A and B are turned on, a supernatural phenomenon occurs. The photons on the screen display particle-like behavior again, indicating that in the quantum world, the causal order of time can be disrupted. The actions of the observer can now determine what happened in the past. Heil's prediction was correct. The latest version of the delayed choice experiment was conducted by Australian scientist Professor Andrew Truscott, and their research findings were published on May 25, 2015 in the journal Nature Physics. The title of the article even includes Wheeler's name. It's called Wheeler's Single Atom Grating Delayed Choice Experiment. There's a reason why Wheeler is considered one of the greatest thinkers of our time. The world is based on uncertainty at the microscopic level. Time's order can be disrupted. A civilization from Andromeda set off to invade the Milky Way at near light speed. 2 ships left the nearby dwarf galaxy, WLM. Upon arrival, something counterintuitive occurs. One day, the civilization from the Andromeda galaxy prepared to invade the Milky Way, and their fleet set off towards our galaxy at nearly the speed of light. At the same time, 2 reconnaissance ships departed from the nearest dwarf galaxy, WLM. Ships at the Milky Way and Andromeda galaxy see unexpected events. In Andromeda, the fleet might not have left while the Milky Way war is over. This is because time changes with motion. In the Andromeda galaxy, the fleet may not have even set off yet, while the war in the Milky Way has already ended. Why does this absurd result occur? It's because, relative to each observer, the time in other coordinate systems changes when they are in motion. Results might appear before events in another galaxy, showing causality. Laws are relative. 3 factors affect time: gravity, motion speed, and the observer. We discuss time uncertainty in microscopic and cosmic scales. Some might ask, our world isn't microscopic or vast. In our low-speed world, time follows causality. How does this relate to reality? It relates significantly. There are 3 factors that influence the change in time: gravity, speed of motion, and the observer. At the same time, we also introduce the uncertainty of time in both the microscopic world and the cosmic scale. Some friends might ask, our world doesn't belong to the microscopic realm, nor is it the vastness of the universe. In this low-speed world we live in, time follows the laws of causality. What does all this have to do with our reality? Actually, it has a lot to do with it. Because in the real world, observers can also influence the causal order of events. To delve deeper into this issue, we first need to introduce the concept of the light cone. The light cone was first proposed by Einstein, and later expanded upon by scientists like Wheeler and Penrose. It has now become one of the fundamental tools for describing phenomena in physics and astronomy. The so-called light cone is a shape composed of the range of light propagation from the past and the future, with the slope of the light cone representing the speed of light. The center point represents the event that is currently happening, or it can also be seen as the time at which a certain observer is situated. All causal relationships must fall within the range of this light cone. Suppose an event occurs outside the light cone. That event would have no relation to the observer. For example, Betelgeuse, located in the Orion constellation, is a red supergiant star and one of the largest stars visible to the naked eye. Scientists estimate that Betelgeuse will explode within 100,000 years, which is just a blink of an eye on a cosmic scale. So, in reality, Betelgeuse could explode at any moment. However, since Betelgeuse is about 500 to 600 light-years away from Earth, if Betelgeuse were to explode right now, we wouldn't know about it, until the light from the explosion reaches Earth in 500 to 600 years. So, by the time you watch this video, the event of Betelgeuse's explosion is still unknown. Outside of our light cone, we can't really say whether a world exists or doesn't exist, because that question doesn't have any practical meaning. In other words, whether an event exists or not depends on the observer. If there are no observers, then time doesn't exist at all. Our universe is the same. The laws of causality for time, space, and events are all built upon the strange quantum world, which is based on a vague principle. This means that the world itself is also vague. The existence of the world is because there are 8 billion people observing the Earth, so the Earth is infinitely close to truly existing. The fewer people there are, the closer this world becomes to being vague and uncertain. If one day there were no intelligent life in the universe, the entire universe would cease to exist. This illustrates the relationship between the observer and the world. The world is not a static existence. Its existence is probabilistic and is directly proportional to the number of observers. This is how our physical observation creates the world. Some friends might say that these issues are too macro and seem unrelated to our everyday lives. Understanding the light cone concept is meaningful. It reveals what a secret is. Secrets are about the observer and information transmission. If a military never mentions it again, they halt information transmission. Once a military is gone, the event is independent of all light cones, and the alien abduction case remains a secret. What does having a secret mean? There's a saying, only things known by one person can be secrets. Once the military is gone, that event becomes independent of all light cones. The alien abduction case will forever remain a secret on our planet. This is actually the essence of a secret. What is a secret? There's an old saying, only things known by one person can become secrets. That's all for today's story. At the end of the program, I also want to update everyone on my recent situation. Many friends have noticed that I haven't updated the program for over 2 months and have been asking about the reason behind it on the website's backend. I really appreciate everyone's concern. I haven't updated because I've recently developed a thyroid nodule, and I'm feeling quite uncomfortable in my throat. I've been feeling a strong sense of discomfort, and Xiaoyan has also been having a tough time. I haven't been able to make any programs for the past 2 months because I've been focused on my health. The doctor has advised me to get checkups every few months, which I didn't expect. It's really touching to see so many friends concerned about me, leaving messages of support and encouragement. Seeing everyone's messages really touches me. For a content creator, being able to make so many friends through the program is definitely something to be happy about. I can't repay everyone's care and kindness in any way. The only thing I can do is to make the program better and explore this mysterious and beautiful world together with all of you. So, as I said, welcome everyone to pay more attention to Lao Ming's channel. We'll chat again in the next episode.